Hi, everyone.
All right. So we're starting a module they're going to call inventory management, which covers a lot of different stuff. We'll do it today and tomorrow, I think. It's got some interesting stuff in it. So develop and or implement an inventory management system. And when they're talking inventory management, they're talking really about warehouse or distribution center inventory management systems, which aren't that different from a factory system, but they're a little different. So physical tracking systems. These are necessary to locate items and link them to a warehouse management system. Anybody that's operated in our big plants like Denton or Chile knows what it's like to try and figure out what trailer has got the parts in it out in the parking lot that we're looking for. So I think they use RFIDs on the trailer now out there. So RFID is primary components of the host computer, the reader, the interface, the transmitter, and the tag device. So ideally, every piece of inventory would have a tag identifying what it is, but you got to get the supplier to put that on. It's expensive. So a passive or active radio chip data chip is attached to the products. The retailers use it to track products through the supply chain. You'll see this on clothing a lot. Tagless systems allow the tag to be printed directly on an item. That's probably newer technology. And RFID tags may be used to provide manifests for shipping containers. It's interesting. That have been sealed at the factory. So surety seal or safe seal or whatever the heck they call that, and will allow the container to pass through customs security with greater speed. So if you got this secure seal on there and then you got RFID tags, they can see what's in it and it goes through customs a lot quicker. Very high cost to implement the system. You need a bunch of computers, you need to put chips on the parts, all that stuff. So barcode, what every grocery store uses these days, allows for easy ID of a company's inventory, equipment, and furniture. So barcodes are a pattern of parallel bars and spaces that represent specific characters and numbers. And the universal product code is what most barcodes are made up of. That's used by the retailers in the food industry, just to standardize the bars and what they mean. Also used as intelligent shipping labels. You see barcodes on a lot of stuff. Many industries use different standards that cannot be read by each other. That's not the problem that used to be, but still an issue. Now there's this UDI or Unique Device ID. The Defense Department, I think, is the one that came up with that. Consists of a reader that retrieves data encoded on a machine reading label and a one-of-a-kind identifier. So this is what it looks like. It has the device identifier, the expiration date, lot number, serial number, all that junk. It's called a UDI. Can be used in conjunction with RFID, and mostly what it's used by the government is to track missiles and high dollar volume items and stuff like that. The Global Positioning System, otherwise known as GPS, uses satellites to precisely locate an object on Earth. And the system that we used before GPS was called the MAP, or the paper map. The GPS tracking systems can be used to keep track of inventory. We use it during transport and within the warehouse, sometimes not really, and delivered to the customer. FedEx uses a lot of this technology, and UPS can be integrated with a warehouse management system, which will store the location of the inventory. FedEx and UPS may use that in their warehouses. I don't know. Overall project plan for the warehouse. So a plan for business continuity, a plan for a company to maintain and continue operations in the face of unexpected crisis or disaster. So the warehouses needs these plans for business continuity or emergency operations plans, or what do you want to call them? It could include multiple production facilities, multiple suppliers, and effective production and quality plans. So you got things like employee escape plans, communications, press briefings, when you're going to back up data, shipping methods, alternative sources, disaster drills, maintaining safety stock levels. You can have a one big overarching plan that covers all this, or a bunch of small plans. A lot of this stuff should be covered. Implementation plan starts with describing the as-is state of the plan using the process flow diagram. So this is pretty standard stuff. The as-is and then the to-be. Determine where changes should be made and prioritize. Design a system that will accommodate as many of the changes as possible. Design a transportation plant to move the as-is. I think that's supposed to be a plan. To the to-be system. And overall measures at the strategic level should be set. What are your KPIs going to be? Labor and equipment. Higher labor rates may justify more equipment. So higher labor rates could justify more automation. Flexibility of a system to switch some portion of its operation between human resources and equipment. It's highly desirable. So interestingly enough, a lot of the job destruction, I guess you would call it, in manufacturing that has taken place over the last 30 or 40 years is not due to immigrants coming in and taking jobs. It's due to automation. They just need fewer people. Facility design. A high level of efficiency and high utilization of labor, equipment, and space are all desirable in a warehouse. So you're usually dividing warehouses into these areas: receiving, storage, and shipping. Those three main areas. Some warehouses will operate so that the dock area is a receiving area during the morning and a shipping area during the afternoon. Now, the old PDC down in Renton, that's how they used to operate because they only had a limited number of docks. Specialty warehouses are required for refrigeration and other things like high value items, flammable items, or hazardous material. And how the movement of materials is performed is design consideration. There are four basic models. So there's the inverted T, the cross flow, the corner warehouse, and the through flow. And we'll cover each of them. And I know PPD has a standard floor plan that when they build a new warehouse, and I think it's the corner. It's what they like. So here's the inverted T. So you see here is a T pattern. Loading docks for goods going in and out are located on the same side of the warehouse. So goods going in, goods going out. And low use items are placed furthest away, which is down here. And the high use items are closer to the dock doors. And then you got bulk storage over here. Saves time and minimizes distance for traveling fast moving stock. Here's the cross flow. The goods come in here, go through here, and come out here. Design retains advantages of the T system, this system, but removes the central aisle congestion. So in the T system, this central aisle can get congested with trying to get in and out of these two areas. So high usage, again, are closest to the doors, low usage furthest away. And the corner warehouse, this is what PPD favors a lot. Incoming and outgoing goods at adjacent sides of the same corner of the warehouse. So it reduces congestion during times of high throughput. So stuff comes in and the high volume stuff immediately goes out. It doesn't even get put away. It ships in and out the same day. And then it's as much like the cross flow warehouse. You set up high usage near the doors, medium and low usage. And then finally, the through flow warehouse. So where all the warehouses, or most of them, have the doors on the same side, with the exception of this one. Doors are pretty close together here. The through flow puts them on the ends. And you got your high usage stuff in the middle, and then you go out to the sides. Good aisle space, but all materials must travel the full length of the building. So you got to receive them here, travel the full length, put them on the truck there. So warehouse plan, building up, you can expand the building vertically, but you'll need higher racks, and you'll also need different forklift and picking equipment to get to those high racks without tipping over. Or you can build out if you've got the space. Expanding horizontally is usually cheaper. In addition to square footage, it's important to consider cubic volume of space since you can go up. And vertical capacity requirements relate to the type of equipment that will be needed. This is, again, if you're going to go up high, you're going to need specialized forklifts. Physical constraints, scissor conditions are similar to the cost considerations, type of good, size and weight, special equipment requirements, danger level, value, security, etc. And then what are you going to use in your warehouse? You're going to use fixed or random systems. So in the fixed system, again, you store the same part in the same location on the same shelf every time. And then you have overflow like above it or something like that. In the random system, it's the first available slot. Usually on the automated systems, they're all random because it's just a conveyor belt that's coming around. RFID helps tell the system and you where the parts are at. Customer requirements can vary, frequency, order place, sizes, variety of items, methods, amount, special packaging, etc. And cost considerations. Warehouses can usually earn a higher margin on value-added services, such as unpacking, repacking, line set, basically what our MSS guys do for us. The margins are better than just holding on to stuff. Characteristics that can affect costs, type of products, variety, requirements, size and weight. Heavy stuff is always more expensive. Specialized equipment, state of automation, size of the warehouse, etc. All right. In performing a SWOT analysis for Albright Solar Power's warehouse expansion strategy, Jeff Jones examined the boundaries of business continuity and disaster recovery planning. All of the following are considered strategic elements of business continuity and disaster recovery planning, except what doesn't go with disaster recovery planning? Any guesses? Which one doesn't belong with the others?
I would go with C, selection
Yeah.
of an asset security organization.
Yeah, that's what I would say too. It doesn't really go with the other three. Let's see what these guys say. C it is. Okay. Oh, and I guess we can cover that tomorrow. So that's where we stop today. So you guys can go out on the chat and do questions 1 through 5. And we'll pick up at 10 till. Or if we raise your hand if you get done earlier. 3F8. Hmm. Yeah, I think question 5 is an EOQ question. Which is yeah. Yeah, there's EOQ. All right. Well, we had an EOQ question in there, which we shouldn't have had till tomorrow, but that's all right. All right, let's go over some answers here. Number 1 is Charlie. Is the primary property of a cross flow is that it retains the advantage of the inverted T, but removes central aisle congestion. I actually think any one of the other answers would work, but through flow has the advantage that it achieves good aisle space, but the receiving and shipping docks are on the short ends. And option B is incorrect, because although a corner warehouse system relieves congestion during times of high throughput, the shipping and receiving docks have to be adjacent to one another. Man. All right. Number 2 is alpha. Allowing users to update records will compromise the integrity. You're looking for the thing you wouldn't do. 3 is Charlie. Change notices are used to direct activities to modify a product. They're not used to issue inventory. 4 is Delta, because goods are damaged and therefore not usable elsewhere in the organization. And 5. So here's the formula for EOQ. 2 times the annual usage times the order cost divided by the carrying cost or cost to carry, and take the square root of all that. So 2 times 100,000 pounds, the annual usage, was 200. Then it's $100 for an order. So that gives you what, 20 million. Divided by 1.25 gives you 16 million. And then you take the square root of 16 million, 4,000. All right. Again, EOQ it's taught a lot in school, but it's rarely used in practice because a lot of these things are hard to estimate as far as, what the order cost is and what the cost of carry is and some other things. All right, so we'll finish up tomorrow with more on this stuff. See you guys.
See you, Rick.
Yeah.